Hello everyone and welcome to another video that I'm doing after such a long time. To be honest, I don't really want to bore you all with an explanation for why I was off for such a long time because there were quite a lot of reasons, but I'm not going to go into those. So instead, today we are going to have, I think, what is a very interesting topic. Today I will prove to you how the quadratic formula came by. So I think this is going to be a very interesting video. Now, the method that I'm going to use is called completing the square. You may have used this in like Algebra 2 maths or GCSE maths, depending on where you are in the world, but the process is the same. So here's the objective of today's video. So by completing the square, I will show to you that the universal solution, so all quadratic equations of the form ax squared plus bx plus c equals to 0. And that is x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So before I get started, if you are not sure how to complete the square, I've made a video about it, which I'll probably link either in the description or one of those annotations or whatever. So if you are not sure of exactly how I'm going to do this, please, I highly recommend you check it out. So without further ado, let's get started. So given the equation that we have, so ax squared plus bx plus c equals to 0, the first step that we're going to take is to isolate c to the right-hand side. So to do that, we just subtract c from both sides. So we have ax squared plus bx equals to negative c. The next step is to get rid of a from ax squared. So to do that, because we see that a is multiplied to x squared, we have to divide it from ax squared. Now, because this is an equation, we always have to maintain that the left-hand side equals the right-hand side. So we have to divide both sides and every term by a. So we get x squared because a cancels out for ax squared. And then we have b divided by a times x equals to negative c divided by a. Okay. So, moving on, now we're going to calculate the two crucial values that are unique to completing the square. So b divided by 2 and b divided by 2 whole squared. So b divided by 2 is basically b divided by a divided by 2, which is multiplying by 1/2, and then we get b over 2a. And then b over 2 whole squared is basically squaring b divided by 2a, everything in it, so we get b squared over 4a squared. Now we add b divided by 2 whole squared to both sides of the equation. So we get this, x squared plus b over ax plus b over 2 over 4a squared equals to negative c over a plus b squared over 4a squared. Now the next step is to add the fractions together on the right hand side, basically. Our common denominator is going to be 4a squared. We have to do nothing to b squared because it already has the 4a squared, but for the negative c over a, we need to multiply c by 4a. And so we get this. So we get x squared plus b over ax plus b squared over 4a squared equals to b squared minus 4ac divided by 4a squared. So hopefully the b squared minus 4ac, that looks familiar, right? That's how we know that we're on the right track. Another small little thing, the b squared over 4ac, b squared minus 4ac is also called the discriminant, and we're going to discuss the discriminant in a separate video. So hang tight for that. Okay, so now we can factorize the left-hand side using b divided by 2. Now, if you remember, our b divided by 2 value is b over 2a. And the great thing about completing the square is that you don't have to work out any possible multiples that add up to b over a. You don't have to do any of that because we've already done it. We've used b over 2, and so what we do is we just add. This is how we factorize it, right? So x plus b over 2a whole squared equals to b squared minus 4ac divided by 4a squared, right? So you can easily mechanically factorize the left-hand side using b divided by 2. Okay, now quick little side note about that. If we subtract b squared minus 4ac over 4a squared to the left-hand side, we get this. And if you are an Algebra 2 student or a GCSE Maths student, you may well recognize this as the completed square form or the vertex form. And what this tells us is basically the coordinates of the vertex or the turning point or the minimum or the maximum of the quadratic equation, right? So the x-coordinate is negative b over 2a, because if it's if like a sign is inside a function, then the actual value is the opposite. Okay, and then the y-coordinate is, or the y-intercept, it's the y-coordinate. It's negative because we've subtracted it to the right-hand side of the equal sign, so it's negative b squared minus 4ac divided by 4a squared. So that's just a little side note, and I think that's interesting. So this is the completed square form or the vertex form if we subtract it to the other side. So continuing on with the proof, now we can take the square root of both sides of the equation, right? Because we now only have an x over here by itself. So taking the square root of both sides of the equation would give us x plus b over 2a as plus or minus, because if we square whatever that is, then we always get x plus b over 2a. We get plus or minus the square root of b squared minus 4ac divided by 4a squared. And then we can simplify the denominator of the right-hand side further by saying that x plus b over 2a equals plus or minus the square root of, as we previously discussed, the discriminant divided by 2a, because 2a is a perfect square root of 4a squared. And we're so close now. And then all we have to do is isolate x. And to isolate x, we subtract b over 2a from both sides. And so we get this. The final step, the pièce de résistance, I guess, is to collect the two fractions together. And so we get x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And just to make this look like a formal proof, I put the QED on. So that is the quadratic equation and how it comes from. So I hope you enjoyed this video. Again, I apologize for uploading after such a long time. But otherwise, if you like this video, I'm pretty sure you'll like some of my others. Again, if you are a bit stoked on how to complete the square, I will have probably put, I'll put a link to in the description of my video about completing the square. And so I hope that helps. Thank you very much for watching, and I will see you in the next video. Goodbye.